let's do a little bit of practice on a function problem that we might see. This one on the simpler side, but the same principles and processes do apply. Here we're given a function, okay, f of x equals negative 2x plus 1. And by inspection, we can look at this and we realize that this equation right here is in the form of mx plus b. Doesn't have any squares on it, so we know it's not a parabola. This is going to end up being a line. So that helps us get at least a mental image of what this should graph itself out to. But before we graph this out, we have to come up with some points that we're going to graph. And in the problem, we were given 5 different points. This -3 is an x value. We are going to plug that in to the equation for x. So let's do that for each of these. So I'm going to say f of -3 equals -2 times -3 plus 1. And if I solve this, I get 6 plus 1, because -2 times -3 is 6, and then plus 1 equals 7. Okay, so f of -3 equals 7. If x is -3, this is the y value. So if I were to draw an xy table, let me do that over here. I'll draw a line down as best I can. When x equals -3, y equals 7. Okay, why don't you go ahead and pause the video, solve for B, C, D, and E over here on this side. And then come on back when you're done, hit play, and we'll talk our way through this. Go ahead and pause. Okay, welcome back. Let's take a look and see what you came up with. F of -2 equals -2 times -2 plus 1, which equals 4 plus 1, which equals 5. So when x equals -2, y equals 5. Y equals, whoop, let's undo that. 5. There we go. Let's try f of -1. F of -1 equals -2, and I'm going to substitute the -1 in for x because we were given x plus 1, which gives me 2 plus 1, which equals 3. So when x equals -1, y equals 3. Let's look at f of 0, where x equals 0. -2 times 0 plus 1 equals 0 plus 1, which equals 1. So when x equals 0, y equals 1. And let's try f of 1. I'm going to bring this down here a little bit. So that would be -2 times 1 plus 1, which equals -2 plus 1, which equals -1. All right, so when x equals +1, y equals -1. All right, so we have our points now. Now we want to plot them on this graph over here to the right. Go ahead and pause the video and graph that up. Make sure you're using a ruler to connect the dots. All right, welcome back. Here we go. Let's start plotting our first point. -3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. All right, there's my first point. Let's go to the next one. -2, 5. 1, 2. Then up 5. Then the next one is -1, 3. There it is. Then 0, 1. And then 1, -1. All right, so we got an idea of what this is going to look like. Now I'm going to put up my ruler. Let's bring that over here. Try to line this up as best I possibly can. Almost. That looks pretty good. Let's change my color on this to green. We'll give it a green line. All right, here we go. Oop, I'm moving it. I don't want to do that. There's my straight line using my virtual ruler. Turn that off. And I'm going to put some arrows on this because I have no indication, nothing in the instructions or the problems say that this would be what's considered discrete or it's stopping at 2 points. So there is my line that came from my points. So before I go any further, let's just do a quick review. Going back to the very start of this, here at the initial problem, I was given my function. For each of the 5 problems, I was given the x value. Notice it's inside the parentheses, just like x. They kind of match up in their location. That's how you know you were given x. Then I substituted this x value into the original function, and then I solved for it. And what came out was the y value, because remember, y is the same. Whoop, let me undo this. Y is the same as f of x. This is just y. This is function notation. It's just a different way of writing it. So if you know we gave you x on the inside of the parentheses, the f of x value, what it equals, is the y. And we put that in a table. Now, you don't necessarily have to do the table. You can plot directly from the problem if once you get comfortable with it. Once I plotted my points, my x and y values, use my straight edge to get the line. Now, there is one more question down here. It asks, what is the domain and range of the line in the problem? And why don't you pause the video and go ahead and write out what you believe the domain and range would be. Okay, welcome back. The domain stands for all x values that I can put into the function. So as I go along the x-axis in both directions, I'm going to change colors on that just so we don't confuse ourselves. I'll put my magic color on here, going this way. As I go that way on x, I'm always going to get myself a y value on the line. And I know I'm crooked, sorry about that. If I go this way on the x value, on the x-axis, and no matter where I go, I can draw a line down to the graph. Whoop. There we go. If the line extended down there, here's an example here, here's an example here. So we know it's a function. Every input has only one output. The domain is negative infinity to positive infinity. Now let's take a look at the range. We'll slide this up just a little bit. The range is all the y values that go into the function. And much like our domain, this also is negative infinity to positive infinity. Okay. Now, if this was a parabola, of course, we can ask a lot more questions than this, just like you did on your first test. But I think the purpose of this activity here was really to get us to think about the relationship between the function over here on the left side of the screen and the graph on the right to make sure that we know where the x and y values come from. And then once we get that, we can analyze it using all the questions that we have in the front of our yellow packet. All right. With that, hopefully this worked out well. Ask me any questions that you might have. I'll give you as much feedback as I possibly can. And thanks for working along with me.